So good morning all. So our today's topic is simplification of the CLG. So as we discussed that whenever we have a grammar and we have been asked to convert it into the Chomsky normal form or a Grayback normal form. So before directly converting our grammar into the either CNF form or GNF form, so the first and foremost thing we need to check is so whether the grammar has been simplified or not. Okay. Then once you find that the grammar is simplified, then what we can do, we can convert our grammar into the corresponding normal form. It can be a CNF form or it can be a GNF form. Now the question is, so how do you do the simplification of the grammar? So simplification of the grammar usually consists of three operations. So the three operations are, the first operation is, so you need to go for removing of all the epsilon productions or null productions. Epsilon productions are also called as null productions. Okay, so means in your given input grammar, if you are having any epsilon productions, the first and foremost thing you have to do is you need to go for removing all the epsilon productions. Then the second step of our simplification process is we need to remove all the unit productions, right? Then the third step of simplification process is we need to remove all the useless symbols. Understand? So once we apply all these three steps in our given input grammar, then we can say that we got the simplified context-free grammar. So once we got the simplified context-free grammar, then we can easily convert that simplified grammar into the corresponding normal form. It can be either CNF or it can be either GNF. Okay. Now let us go ahead and see so how we are going to remove the epsilon productions or null productions. Okay. So as part of our first step, let us see how we are going to remove the epsilon productions or null productions. Okay, now let us see here. Now generally we know that what is an epsilon production is. What is an epsilon production is? So epsilon production is nothing but it is a production which is of this form, A derives to epsilon. So whenever you have a production like this, then we can say that, so this is what we call the epsilon production. We call it like a epsilon production. Okay, so sometimes it is possible that, so you will get direct epsilon productions. What do you mean by direct epsilon productions? In the sense, you will get a production like this, A derives to epsilon, or B derives to epsilon, or C derives to epsilon, like that. So we call them like direct epsilon productions. So we call them like direct epsilon productions. And it is also possible that we may also have indirect epsilon productions also. Okay, please try to understand. It is also possible that we may also have indirect epsilon productions. So what is the meaning of indirect epsilon productions? Means, let me write. I have a productions like this, S derives to AB. S derives to AB. And I have one more production like A derives to epsilon. A derives to epsilon. And then I have one more production, B derives to epsilon. B derives to epsilon. Okay. Now please observe in the given grammar, now you can see that these two are the productions which are directly null productions because it is directly deriving the epsilon. You can see here these two are directly they are producing the epsilon, so we can say that so they are epsilon productions. But if you observe thoroughly, I can say that S is also an epsilon production. But how? The reason here is, as we know that A is a A is a variable which is producing an epsilon production, and B is also a variable which is producing an epsilon production in the sense, then automatically when you substitute A as epsilon, B as epsilon, automatically it will result in S also like a epsilon production. Understand? So as A is epsilon production and B is also a variable which is giving an epsilon production, when you replace these two variables with its epsilon productions, so on the right hand side of S, which will remain is, which is nothing but epsilon. Now from this we can say that, so S is also involved in epsilon production, but S is not involved in direct epsilon production, but it is involved in indirect epsilon production. Why I am calling it like indirect epsilon production? Because so S is not directly deriving epsilon. So we are able to get this epsilon production for S only after replacing the variable A with epsilon and replacing the variable B with epsilon. Understand? So here, whenever we go for removing of these epsilon or null productions, the first and foremost step, which is very important step, is we need to identify the nullable variables. Nullable variables. Okay. So please try to understand what is the first step we have to do. We need to identify what are the nullable variables. So nullable variables in the sense, nullable variables are those which are either directly producing the epsilon production or indirectly producing the epsilon production. Please try to understand. So nullable variables in the sense, nullable variables are those which are directly producing the epsilon productions like capital A, or here capital B, or are indirectly producing the epsilon production. What is indirectly producing the epsilon production? Capital S. Now we need to add all those nullable variables to our list. Okay. Then the next thing what we have to do is, now we need to remove. So this is the first step of our removal of epsilon production process. Then the second step is we need to go for removal of one or more occurrences. Removal of one or more occurrences of each nullable variable. Each nullable variable in the productions of our context-free grammar. Productions of our context-free grammar. Okay. I hope now you are not able to understand anything. Let us go ahead and we try to directly work with our example so that you can understand these points. Okay. Now let us observe that this is our input grammar. Now please have a look at this. We have S derives to capital A, S, B or epsilon. A derives to small a, capital A, S or A, B derives to this one. Now this is what the production we have. Now what we have to do is we need to simplify this grammar. So when we want to simplify this grammar, the first and foremost thing we have to do is we need to go for removal of epsilon productions. First we need to go for removal of epsilon productions. So if I want to remove the epsilon productions, the first and foremost thing we need to do is we need to identify what are the nullable variables. What are the nullable variables? Now please check what are the nullable variables are there. Now you can see we have S. S is a variable which is directly deriving the epsilon production. So we can say that S is a nullable variable. S is a nullable variable. Now please check any such variable is there where it is possible for us to add that variable to the list of our nullable variables. Now you can see here capital A is there. When I substitute S as epsilon, but still we will get a small a capital A. It is not becoming epsilon. So we are not going to add. So what about here? When I substitute S with epsilon in both the places, but still we remain with the terminal small b. Okay. Now the only nullable variable which is available in our list is capital S. Capital S. Okay. Then once we have identified this nullable variable, now what we have to do is we need to remove the occurrences of this variable from the production. So what is that production? So first take the first production. S derives to capital A, capital S, capital B. Capital A, capital S, capital B. Now please check how many times this variable, nullable variable S is appearing. So this variable capital S is appearing for only one time. Now when I remove the occurrence of that variable S, now I am going to get the production called a capital AB. In the sense what I am doing here, this S has been replaced with, please try to understand, this S has been replaced with its equivalent production called a epsilon. So when you substitute this or when you replace this capital S with the epsilon, what will remain here? So the thing which will remain is capital A, capital B. That is what I am writing over here. Okay. Then go for next production. Capital A derives small a, capital S. Small a, capital S. Out of this production, so S has been repeated for only one time. When you remove the first occurrence of this, then the productions which will remain will be small a, capital A. And in addition to that, one more terminal production was there, small a. Then we are going to write as it is. Okay. Then go for B productions. Go for B productions. The B productions has been something like this. So capital S, small b, capital S. Now this is the trickiest part for us. Now please have a look at this. So now we have a nullable variable S which has been occurring more than once. More than once. Now what we have to do is, now we need to remove one occurrence at a time from the given production. So first what I will do, I will remove the left hand side capital S. Once I remove this left hand side capital S, the part which will remain is small b, capital S. Small b, capital S means this part will remain. That is the first occurrence. Then once I remove the right hand side capital S, the part which will remain is capital S, small b. This is what is going to remain. Okay. Now I slowly what I am doing, I am removing one occurrence at a time. Now I am going to remove both the occurrences of capital S in this production. That is, we go for removing the left hand side S, this part, and at the same time we are going to remove this right hand side S also. When you remove both the S, which is there on the left hand side and right hand side, the part which will remain will be terminal small p. Okay. So like this, what we are doing, we are removing the nullable variables, so which are available inside the given production. Then these two are already available, so we are going to add these two to the list as it is. Understand? So that is why, that is the reason why I told you that. So slowly what we have to do, we need to go for removal of one or more occurrences of each and every nullable variable available inside the context free grammar. Understand? So this is how we are going for the removal of the nullable variables. Now please observe, this is your input grammar which is consisting of the epsilon production. You can see here we have an epsilon production. But if you observe thoroughly over here, this is my output production which I got after removing the nullable variables so present in the grammar. Now please check these three productions. Now in this, please check this context free grammar. Do you find any epsilon production in this grammar? Please check. So here we don't have any epsilon production. With A also we don't have any epsilon production. With the B also we don't have any epsilon production. So from this we can say that, so we have removed the so epsilon productions which are available inside the grammar. Understand? So this is how we are going to remove the epsilon productions which are available inside the grammar. Okay. Now let us go ahead and take one more example, and we'll see one more example. how to remove the epsilon productions available within the grammar. Now this is our grammar. Please have a look at this. This is our grammar. Now from this grammar, now we need to remove the epsilon production. So here I am going to write. So remove epsilon or nullable production. Removal of epsilon productions. Removal of epsilon productions. So in order to remove the epsilon productions, first of all, we need to identify what are the nullable variables. Please have a look at this. Please tell me like what are the nullable variables we have. So with S, we don't have any direct epsilon production, but with X, we have a direct epsilon production. So we can say that the only nullable variable available will be capital X. But with Y, we don't have any production available. Even if I replace this X with epsilon, but still we will get the variable Y. So S is not a nullable variable. So the only nullable variable which is available in this grammar will be X. Now what we have to do now, we need to remove the nullable variable available in this production. So what is this production? S derives to xy. S derives to xy. So as there is a production called S derives to xy is there. Now what we have to do now? Please check. So we need to remove one or more occurrences. So what is the nullable variable? We have capital X. So as this capital X is appearing for only one time, so we go for removal of its first occurrence. Then the variable which will remain will be capital Y. Then what about X? X will be small a, small bb, or a capital X, b small b, a capital X small b, or now please check here also we have a X variable, mean nullable variable is available. So this nullable variable has been repeated only for one time. Just go for the removal of first occurrence. Now we will get AB, small AB. Then what about Y productions? The Y productions will be small c or small c capital Y. Small c or capital Y. Understand? So this is how we go for the removal of epsilon productions. Now if you want, we can work out with one more example also. Okay, now let us take this example. So we try to work with this example also so that it will be very clear for you. You should not get any doubt regarding how we are going to remove the epsilon productions. Removal of epsilon or null productions. Now please check. For that, we need to identify what are the nullable variables. Now add it to the list or set. You can see here. So what are the direct nullable variable? We have X because there is a production called X derives to epsilon. X derives to epsilon. Now please check any other indirect productions are there which will derive epsilon over here. Now if you observe over here, there is a production called Y derives to X. And we already know that X is a nullable variable which will give epsilon for us. Then automatically, so Y also going to become the nullable variable. So I already told you that, so this is X is a directly nullable, but Y is not directly nullable, but it is indirectly nullable. How it is indirectly nullable? Because there is a production called Y derives to X, and we already know that X is a nullable variable, then automatically Y is also going to become the nullable variable. Now we go for removal, removal of the epsilon productions. I mean removal small a capital X, small b capital X. Now from this production we need to remove the occurrences. Now please observe x has been occurred for twice, two times. First we go for the first occurrence. What is the first occurrence? Now I will remove this x. When I remove this x, then what will be remaining? Small a, capital small b, capital X. Or now go for the second, go for the second x removal. Then we will get small a, capital X, small b. Or now go for the removal of both the occurrences of this x. When we remove both the occurrences of this x, we will get AB. We will get AB. So now we have removed the epsilon projections from x. Then we need to do the same with the x also. X derives to A capital Y. A capital Y. And we already know that y is a nullable variable. So this y has been occurred for only one time. So when we remove that, only a will remain. And then again we need to do the same for by also. By. And in this by, we know that y is a nullable variable. Once we remove the occurrence of that, then automatically the terminal will remain. What is that? B will remain. Then what about the last one? Y derives to x or c. So here we have x, so which is directly available. So we are going to make use of this statement as it is. Okay, we are going to write it as it is. Why? Because if you remove this first occurrence of this x in the sense, now here what we will get again, we are going to get the epsilon projection. Okay, now so we are putting this entire effort only for removal of the epsilon predictions. Now when you remove the first occurrence of this, what will remain over here? So here we will get the epsilon prediction. So that is the reason why. So we will get our y prediction like this. Okay, now this is how we are going to remove the epsilon predictions or null predictions which are available inside the given graph. Okay, so this is the process which we are usually going to follow. Okay, so that is what the first step of our simplification process is. Now let us go ahead and let us try to understand what is this removal of unit productions. Removal of unit productions. So let us see what is this removal of unit productions is. So first of all, let us know what is a unit production is. So whenever we have a production called A derives to B, something like this, A derives to B. If there is a production called A derives to B, where the left hand side should be at most one variable and the right hand side must be having at most one variable, we can say that, so this type of productions will be called like unit productions. Unit productions. Okay, so please try to understand. So if I want to say some production like unit production in the sense, the left hand side must be at most one variable should be there and the right hand side must be at most one variable should be there. So then we can say that, so this type of productions are called unit productions. Okay, now when we have this type of productions, now we need to go for removing all these type of unit productions. So how we are going to remove these unit productions in the sense, the idea is very simple. What do you have on the right hand side of the production? We have a variable capital B. Now as it is a variable, must and should for this variable, we will be having some productions associated with it. Now simply what we have to do is, we need to replace this variable B with its equivalent production. So let me tell you one simple example. Let us take one simple example. We have a production like this example. So let us observe that S derives to capital A, capital B, and here we have capital C. We have a production like this, capital C. And there is a production called A derives to AB or AB or A. This is the A production. And we have a production B derives to small cd or d, small cd or d. And we have a production called C derives to ABC. We have production called capital C derives to ABC. Now if you look into this entire grammar, So we have a unit production associated with S. What is that unit production? S derives to C, capital C. Now what we have to do is, now we need to check whether there is a C production available or not. See here, we have a C production available. Now in the place of this capital C, now we are going to replace this capital C with its equivalent production called the small ABC. Now please check on here. Now the answer will be, the answer which we are going to get after removal will be S derives to capital AB, or this time it is not, this time it is not capital C. This is not capital C. It will be small ABC. Now here what we get, so now we are going to use this production. So it will be like this. So A production will remain and B production will remain. Then what happened to C? Now we don't have the necessity to make use of this production C. Why? Because this production C has been already replaced with its equivalent production. You can see small ABC. See why I am removing this production C in the sense from my answer, in the sense, the reason for that is, apart from this unit production, this C is nowhere involved somewhere in your productions. That is the reason why I am going to remove this unit production. Okay. Now let us go ahead and check whether there are some unit productions are available inside our grammar or not. Now please observe over here, this is our grammar what we have taken. So here after removing the nullable variables, so these are the productions which we are going to get. Please check any unit production is there available inside in this grammar or not. Please check. See here, now we go for a removal of unit productions. Removal of unit productions. Please check any such unit production is available inside this grammar or not. Now let us write one by one. We have S derives to capital A, capital S, capital B, or AB. So here we don't have any unit production. Then A derives to small a, capital S, or small a, capital A, or small a. So here also we don't have any unit production. But let us go for B. When we go for B, we have SB, SBS, no, and here also BS, there is also no unit production. SB, no unit production. B, no unit production. But here you can see, here we have got capital A. We got capital A. Now once we got capital A, means now we have a unit production available. Okay. So what is the unit production we have identified? B derives to capital A. Okay. So now here I am writing, in the given grammar there is a unit production. So that is, what is that unit production? B derives to capital A. B derives to capital A. Now what we have to do now? This capital A has to be removed and it has to be replaced with its equivalent productions. What are the equivalent productions? Small a, capital S, or small a, capital A, or small a. So this is where I am going to place all these things. Okay. Then followed by small bb. Followed by small bb. Understand? So this is how we are going to remove the unit productions. Now let us go ahead and check in this example whether there is a possibility that we have any unit productions available or not. So here let me write removal of unit productions. Unit productions. So let us go ahead and write our grammars. S derives to xy. Wait a second, let me change the format. xy or now please check what we got. Capital Y, single variable is available, means, so let me write here, in the above grammar, there is a unit production. What is that unit production? S derives to Y. s raised to y. In the sense, now in the place of y, what we have to do, we need to replace with its equivalent production. What is that? C or cy. C or cy. Understand? Then what about x productions? We have x productions, small a b b or axb, axb or ab. So we don't have anything to do with this one. And go for last one, y productions. Y productions are small c or small c capital Y. Okay, so like this, what we did, we have removed all the unit productions available in this grammar also. Now let us take our third example and check whether there is any unit productions available or not. Now please observe here. Here we don't have any unit production. So with S we don't have any unit productions available. With X also we don't have any unit productions available, but with Y there is a unit productions. Yes. So now let us go ahead and write down removal of unit productions. Removal of unit productions. So this entire thing I'm going to copy as it is. Okay. So here I'm writing in the above grammar there is a unit production. There is a unit production. What is that unit production? Y derives to x. Now in the place of x, what we have to do? We need to substitute or we need to replace with all the x productions. Okay. So like this, what we will be doing? We are going for removal of the unit productions available inside the given grammar. Understand? So these are the first two steps as part of our simplification process. Okay. See, please observe why I am following this procedure in the sense. So when you go for removal of the epsilon productions, then there is a possibility for us that inside the grammar, there is a possibility for us to get more number of unit productions. So that is the reason why first we go for the removal of epsilon productions, then we go for removal of unit productions, then only we go for removal of useless symbols. Okay, I hope you are able to understand the removal of epsilon and as well as unit productions. So let us go for our third step of simplification process, which is removal of useless symbols. So this removal of useless symbol part topic is a bit tricky and bit confusing also. But let us we try to do this topic in a simple manner. We try to present in a simple manner. Now, first of all, before going to remove, see, the idea is very simple. See, what we have to do here, we need to identify the useless symbols and we need to remove those useless symbols from the grammar. That's it. That's it. That is what we are doing with the help of this removal of useless symbols. But the question is, so you need to discriminate, so which variable is a useful variable and which variable is the useless variable. Now the question is, so how do you identify, so which variable is a useful variable and which variable is a useless variable? Now here comes the answer for this. So let us go ahead. Now I am writing over here. So a variable is said to be a useful variable. Please try to understand. So a variable is said to be a useful variable if and only if it is if and only if it is generating, please try to understand, if and only if it is generating and reachable, if and only if it is generating and reachable. Now please try to understand. See, when can we say some variable like a useful variable? When can we say some variable like a useful variable in the sense? So when the variable is generating, when the variable is both generating and reachable. See here, I have used the I have used the term called and in the sense, so it is mandatory that the variable, whatever the variable you are calling like a useful variable, you are calling it like a useful variable, that variable must be generating and must be reachable. In the sense, these two conditions has to be satisfied. Now the question is, so what is a generating variable? What is a generating variable? Let us go ahead. A variable is said to be generating. A variable is said to be generating if there exists a production something like, so a derives to w. A derives to w. For example, a variable capital X, a variable capital X is said to be generating if and only if, so if and only if this X has to derive some W. What is this W is? W is nothing but string of terminals. String of terminals. In the sense, we can say that we can call a variable like a generating variable when we are able to generate a string which consists of only terminals using this variable X, then we can say that such type of variable is a generating variable. Okay, so we'll discuss in examples also where it will become very clear for you. Okay, then next one, what is this reachable variable? So reachability in the sense, a variable X is said to be reachable if we are able to reach, from the start symbol of the grammar, if it happens, then we can say that that variable is a reachable variable. Okay, now let us go ahead and let us see our problem here. So far what we did here, see here, we have removed the uh, null productions from the grammar, and we have removed the unit productions also. Now we need to identify, or we need to remove removal of useless symbols. So if I want to remove the useless symbols in the sense, so first of all, I should know what are the variables which are generating. First, we'll see what are the variables which are generating. Generating variables. Generating variables in the sense, the variables which are deriving strings of terminals. Now let us see, we have three different variables available in our grammar: capital S, capital A, and capital B. Okay, now let us check whether the variable capital A is generating or not. Now please check, capital A is deriving some terminal string directly or not. You can see here, capital A derives to small a. Is it deriving directly or not? Please check. So this generating can happen either directly or indirectly also. Understand? So this capital A, please observe, it is directly generating a terminal string. So hence I am going to add it to list of generating variables. Then let us go ahead and see B. So B is a variable. Please observe where it is directly generating a terminal string small b or small a or small bb. It is also generating. So I can say that B is also going to be added to the list of generating variables. Now, when we got A and B both are generating, now let us go ahead and see whether S is also a generating variable or not. Now, when you look into S, please observe, when we look into S, there is a production called AB. S derives to AB. Now, when we know A and B are generating variables, now automatically, so S is also going to become a generating variable. How? When just substitute small a in the place of capital A, and any of the B production like a small bb or small a or small b in the place of capital B, automatically you will get a set, I mean, you will get a terminal string. Now we can say that S is also a generating variable. Okay. Next, we need to check reachable variables. Now we need to check reachable variables. Reachable variables in the sense, so from the start symbol, capital S, how many variables are there? Three variables are there, A, B and S. Now whether it is possible for us to reach the other variables or not. From S, is there any production with which I can go for capital A? Yes, there is a production called ASB. And from the start symbol of S, is there any production where I can reach capital B? Yes, there is a production called ASB or AB. Now I can say that we have the reachable variables A comma B. Now from this we can say that all the variables, all the variables are useful variables. Hence, there is no useless symbols or useless variables. Useless variables are symbols. Now, after removing all the useless symbols, so we are going to get the same grammar as it is. We'll get the same grammar as it is. Okay. Now, this is what we mean by generating variables and as well as the reachable variables. Now let us go for this production. Now just take this production. So here we look into our third one. See here. So removal of useless variables or symbols. Useless variables are symbols. So first we need to identify what are the generating variables. So what are the generating variables? How many variables are there? First of all, check. We have capital S, we have capital X, we have capital Y. So now please check whether X is generating or not. Yes, it is generating. How? There is a production called small a, small b, a, b, b. It is directly generating the terminal string. So X will be added to the list of generating variables. Y is also a generating variable. How Y is a generating variable? Because it is directly deriving the terminal string. So Y is also a generating variable. Then when X and Y both are generating variables and there is a production for us called S derives to XY. Like this also I can say S is generating, or there is a production directly available for S which is nothing but S derives to small c. Now we can say that S is also a generating variable. S is also a generating variable. Okay. Now please wait a second. Fine. Next, what is the next one we have? We have reachable variables. We need to identify what are the variables which are reachable. So what are the reachable variables? Now this is our start symbol of the grammar. From S, is it possible to reach the variable capital X or not? There is a prediction with which I can go for the variable, I can reach the variable capital X, because S derives to XY means I can reach capital X. And is there any projection with which I can reach capital Y or not? Yes, I can reach capital Y also from the start symbol. So the reachable variables are X and Y. Means, so here we can say that there are no useless symbols available in the above grammar. So these all the predictions are going to be useful predictions. All these are going to be useful predictions. Now let us try in the third scenario. I think in third scenario also we don't have any useless predictions. You can see here S is generating directly. S derives to AB. S is generating. X is also generating. You can see X is generating small a and small b. Y is also generating. And from S, it is possible for us, we can reach capital X. Please observe here, in this scenario, from S, please pay attention. This is very important. From S, it is possible that we can reach only capital X. You can see here, from S, we can reach only capital X. Okay, but it is not possible for us to reach capital Y directly. Capital Y directly. But what we can do with the help of these X productions, can we reach Y or not? You can see here there is a production. So how we can do that? So let us write one. There is a production called A small x, B small x. Now X is reachable from the start symbol. Yes or no? But Y is not reachable. But we have some X production which is involving Y. Now I am going to take that. You can see here. So small e, and I am going to replace this X production with this production called as small ay. Small a capital Y. Small a capital Y. And then this will be small b capital X. Now please observe, from S, is it possible for us to reach Y or not? But this time we are not able to reach it directly, but we are able to reach this variable Y indirectly. Indirectly. That is also we need to consider. That is also we need to consider. Understand? So as in this productions also, now let me write here. So here I will write very clearly. So removal of useless symbols. Useless symbols. Okay. So here I am writing in the above grammar. In the above grammar. So X is directly reachable. X is directly reachable, but Y is indirectly reachable. Y is indirectly reachable. So how I am saying Y is indirectly reachable? The reason for that is there is a production S derives to small e capital X bx, and this X production I am going to replace it with a small a capital Y, where it has been involved with Y production. In the sense, from the start symbol of our grammar, we are able to reach the variable X and as well as variable Y. Now like this, we can say that, so we have a useless variable or not inside our grammar. So from this examples, so I can say that we don't have no useless variables are available. So hence we are going to write our grammar as it is. Okay. Now this is how we are going to do the simplification of our grammar using the 3 steps. So what are the 3 steps? The first one is removal of epsilon productions or null productions, and then removal of unit productions, and then third one is removal of the useless symbols. Okay. So that's it for today's class, and we'll meet you in our next class. Thank you.